A body starts from rest and accelerates, question 13, uniformly in a straight line until it reaches a velocity of 40 meters per second in 8 seconds. Notice, they now put full stop. It then travels uniformly, constant speed, at uniform velocity, acceleration, or you say at constant velocity, acceleration is 0 for 12 seconds, after which it is uniformly retarded and brought to rest in 5 seconds. Calculate acceleration, retardation, total distance covered. So this is a typical graphical representation, or you say velocity time graph question. And this type of question, in order to solve it, we'll employ the measures. We'll employ all the needed measures for a graphical velocity time graph question. So let's do it. Velocity time graph. Or we normally say it's graphical representation of motion. So let's say the body starts from rest. That means u is equals to 0. When the body starts from rest, u is equals to 0 and reaches a velocity of 40 meters per second is in 8 seconds. So v of 40 meters per second in time 8 seconds. So full stop. So let's, using v equals to u plus at, the second equation of motion. Now that this is the same thing as in v equals to find acceleration 0 and v is 40 plus 80 and a is 8 and t is 8. So this is the same thing as saying 40 is equals to a8. Divide both sides by 8. So that we have that a is equals to 2 here 4, 2 here 20, 2 here 2, 2 here 10, 2 here 1, 2 here 5. A is equals to 5. Alright. And okay, let's I forget. Remember there is a meter per second square. So our acceleration is 5. And the first time t1 is 8 seconds. Okay. Then they say it then travels uniformly for 12 seconds. Then travels uniformly for 12 seconds. That means t2 is equals to 12 seconds. After which it is uniformly retarded and brought to rest in 5 seconds. Uniformly retarded, that is deceleration, brought to rest v equals to 0 at v equals to 0 in 5 seconds. So t3 equals to 5 seconds. So if you calculate this, the total time is like 25 seconds. So that is 8 plus 12 is 20 plus 5 is 25. Then brought to rest, the v there, v equals to 0 at rest. When you hear brought to rest, so the v there is 0. So let's now make use of the things we have and see if we can plot the acceleration time graph, the velocity time graph. And we know that the slope of gradient of velocity time graph is acceleration, because that's what will be in there. So let's try to use our values now. So let's say at this end that what we have here is time in seconds, and what we have here, I'm not using my ruler, but you understand, velocity meter per second mm, and the slope of displacement time graph is velocity, while the slope of velocity time graph is acceleration. So notice that if I have this, let's say, notice that velocity given to us, this one is a very simple question. They gave us velocity to be 40. Let's say here is 0, here is 10, and all the way 20. Let's say here is 30, let's say here is 40. I don't need to be writing meter per second. Once I write this, it's okay. Same thing with when you're plotting graph. Just write it once, it's okay. So now, let's say here, what I have here is like, okay, let's say here is 5, 10, 15, 20, 25. Let's say this is like the scale. So let's say in between here, let's say I have 8 here. Let's say I have my 8 seconds. My 8 seconds here. Let's say I have my 8 seconds here. Now, remember that the next time that it happened is 12. And 12 plus 8 is 20. So at this point, so this is more like, let's say I come here and indicate it. 12, 8. Then another 5. So altogether 25. So I'm just trying to indicate it so that you know. Okay. So now, because some students find it hard to do all this line up. So you're not supposed to come inside and do it and do this thing, but I'm just trying to use it to teach you. Now, they said it accelerates. Acceleration always go this way. So it does an acceleration and it gets to 40. Okay, see the question. A body starts from rest and accelerates uniformly in a straight line until it reaches a velocity of 40 meters per second in 8 seconds. It then travels uniformly. So that's here. Now let's say at this point it travels. Okay. God, what am I doing? Sorry. See, the good thing is that you now know how to get the time. So let's say this is my graph. Let's say this is my graph, and this is the 40 meter per second, and let's say this is the 8. So it moves here and gets to the 8. Then it maintains a constant speed. Remember I told you constant speed is always this way. Then comes down after 12 seconds. 12 plus 8 is 20. Then before retarding in another 5 seconds. So let's say this is the point 25. So this is what you should have. So this one, I'm using this one to teach you so that you understand what the concept is all about. So the mistake I made that made me leave this to come here is because this acceleration made 40 and is at 8 seconds before moving. And then maintaining a speed at for 12 seconds, which is 12 plus 8, 20, then before coming to rest. So this is how it should be. So if I know this, I'll simply notice that what this means is that I've been able to plot the acceleration velocity time graph. So what I need to know now is that constant speed, acceleration, deceleration. So they asked me to find acceleration and I've gotten it. Acceleration is 5. Retardation, we've gotten it now. Shebi, okay, we can still get it. We'll get it. Shebi said at rest in 5 seconds. We'll still get it. So I think I believe at the time when it comes to rest, okay, let's try to do it. At the time where it comes to rest, v is equals to 0. V is equals to 0. Then my u, initial velocity is not given. Shebi, I was not given initial velocity. So if at the point when it's coming to rest, it's traveling with it traveled and accelerates to this 40 meter per second, then okay, so there's no use, because we are not giving you at this we were not given initial velocity, and I don't want to call this 40 at that point. You understand? I don't want to call, so we're not giving you, but what we can do is say, since our acceleration, see the height of our acceleration, and this we said, they said this is 5 meter per second, and notice that this is the deceleration. So that means as it's decelerating, it's almost the same height. So the only thing is that this one is positive 5, this one is negative 5 meter per second square. So our deceleration or retardation is equals to negative 5 meter per second square. So let's find the total distance covered. And for total distance covered, I normally teach my student, the first thing I normally teach my student is say, since the is looking like this, just bring out the triangle, the triangle, bring out the part that looks like rectangle, then bring out the other triangle. That is from this setup. It's not always that you have it to be this way. So remember that this one is half base times height, this one is length times width, this one is half base times height, and then check what is here, 8, what is here, 12, what is here, 5. Then the height is the same, which is 40. So all I need to do is to say half 8 times 14 plus 40 times 12, then plus half 5 times 40. So let's just do the math. If I do the math, I'll simply have 8 times 40, 320 divided by 2, 160, 320 over 2, 160 plus 40 times 2 times, are you kidding me, 12, 480, 480 plus 5 times 40, 200 divided by 2 plus 100. So you see that the distance, I want to tell my student distance. Remember I told you distance and displacement are the same thing, but it's just that displacement has direction. So the distance will now be 160 plus 480 plus 100. So you now get 740 meter, and that's your final answer. This is the simpler method, but sometimes you see some textbook, let's still do their method. They do, since this thing, if you look at this looks like trapezium. So what they do normally is they say, let this be B, let this be A, then let this be H. So they use area of trapezium, which is half B plus A, then times H. And you know that everything here, if you remember, everything here, see now, everything here, if you remember, from this point to this point is 12. That is 12. So if you remember, everything here, y from here to here is 25. That is 25 minus 0. So let's do it. We now do half 12 plus 25, then times 40. Let's check. 12 plus 25, 37. 37 times 40 divided by 2. Okay, so 37 times 40 divided by 2. So you get 1480 half. You get 740 meter. So this is how you go about it. So you can use area of trapezium to get it. So distance equals to area of trapezium, which is equals to 740 meter. You can use this method. There's another method, which is doing it, you do the displacement of the first part, of the second part, and the third part, but I don't advise my students doing it that way. So these are the two methods to use. Thank you. Remember to subscribe and share this video. God bless you.